All right, so we're in chapter 12, congruence through constructions. What does congruence mean again? Yeah, same, identical. Because two things are congruent means they're totally identical in every way. So we're going to start with triangles. And the question, well, there's the Common Core, grade 7, draw, construct, describe geometrical figures, describe relationships, solve problems, blah, blah, blah. I'll let you read that. They do this in the 7th grade curriculum. So what we're going to be doing, some of what we're going to be doing. So I want to make you stronger than that. That's always the deal with teaching. They make you go well beyond what you teach so that you're then a master of what you teach. So I want to make you strong so you can easily help those younger folks that would be doing this stuff. So let's start with triangles. How much info do we need in order to prove that two triangles are identical? Congruent, same word. So we wanted to know that two triangles are really identical. Let me just make up a couple of triangles here. So if I have like that triangle and then over here I have that triangle, they sort of look identical, don't they? What would we have to know to find out those two triangles really are identical? What if we knew the three sides? What if we knew this was like 2, 3, and 4, and this was 2, 3, and 4? So then we say, okay, well, yeah, the three sides are all the same. Does that mean that everything has to be the same? What about the angles?
Yes.
Couldn't they have different angles, maybe? Right? If we want to know they're totally identical, totally identical means the three sides are the same and all the three angles are the same. All 6 things, 3 sides, 3 angles, are the same, but it turns out they're shortcuts, which some of you already know. Do you remember those from a little bit of your geometry background from your schooling? You don't actually need to know all 6 pieces. If you read this paragraph, you'll see what it's saying. You don't really need to know all 6 pieces of information. If you just know side, 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 that's our first axiom. If you just know the 3 sides of one triangle are the same as the 3 sides of another, the angles have to be the same. They have no choice. It's automatic. So what we're basically looking for in this chapter is what's the least information we can have, and then that'll be enough to know the two triangles are totally identical. Well, one way is the side, side, side. That's all you need. You don't need to know all 3 sides and all 3 angles. I mean, that'd be great. If you had all that, then for sure they're identical. But you don't need to have all that. If you just know 3 sides are the same as 3 sides in another triangle, then that's enough. They've got to be totally identical. All the angles have to be the same. They're identical in every way. They're congruent. Side, side, side. You can kind of picture it with this little shape they're giving you here. Can you picture it if you pinned the 3 corners, right? So those angles are flexible, right? There's like pins there so they can open bigger and smaller. But really they can't once you have all 3 sides in there. Do you see how the 3 sides determine the angles? That's the feel they're trying to get. Probably be good if I physically had that here, right? Can you picture the mechanism? If I pin together 2 pieces of wood, right, then that angle's flexible. I can make them bigger or smaller. But once you pin in the 3rd side, there's no more flex, right? I can't make that angle any bigger or smaller because that side right there is determining the angle, isn't it? So the 3 sides do determine the angles, don't they? So it makes sense that if you know 3 sides, you know everything about the angles. It fixes it, and that's true. And here's some examples of that. So these 2 triangles right here, they have to be identical, congruent, in every way. Why? If you can you see that diagram okay? Because they have a 2. Here, maybe I'll write it in if it's hard to see. A 2 here, and a 2 here, and a 3 here, and a 3 here, and a 4 here, and a 4 there. So they have the same 3 sides. So those 2 triangles must be fully identical in every way. All their angles, all their sides, congruent triangles based on side, side, side. How about part B over there? What's up with part B? Do those 2 triangles have to be identical? Can you see them? Let me put the numbers in. This is an 8, and this is an 8. This is a 5, and this is a 5. Nothing about the angles, just that. So, do those 2 triangles have to be fully identical in every way? How do we know?
Because they share the 3rd side.
They share the third side. Yeah, that dotted line right here, that's a side for both triangles, isn't it? So obviously it's the same as itself. So therefore they have three sides the same. They both have a 5, they both have an 8, and they both have that dotted line. So yes, they're identical in every way. So that means they're congruent, identical in every way. And so what that means is, for example, this angle must be the same as that angle, huh? Now we know that because, again, those triangles are identical, we now know. Because they have the same three sides, everything else must be the same also. They must be fully identical. So those angles must be equal. This angle here must be the same as that angle there. And the top angles those two must be the same. Everything must be the same, right? All right, on we go. There's other three-letter combos. Remember this? Side, angle, side. That's enough information to prove that two triangles are identical. And angle, side, angle. That's enough information to prove that two triangles are identical. There's all kinds of three-letter combos that are enough information to prove that two triangles are identical. I'm going to whip on forward because we got a whole bunch of homework problems I want to get to for you. So here's another one. Angle, angle, side. That's enough information. So we're finding all these three-letter combos that are enough information to prove, just knowing those three things, to prove that two triangles are identical to each other. And by the way, the order matters. Back over here, when we say side, angle, side, we mean two sides and the angle between them. Right? That angle's between those two sides. So, and here we mean the side between two angles. You can see it in the picture here. This is a 4 and a 3, and we have the angle between. And this is a 4 and a 3, and see how that's angle in between them, right? Whereas in this next one, notice it's angle, angle, side, so that side is not between. That side's on the side, right? That side is not between those angles. It's some other side that's not between them. But that's enough information also. So we're finding all these three-letter combos that are enough information to prove that two triangles are identical. All right, well then what's the story? Does basically every three-letter combo, and we've had a whole bunch of them, does pretty much every three-letter combo prove that two triangles are identical to each other? Is it almost always enough? Does anybody know? Anybody remember from your geometry? I didn't, personally. I'd be impressed if you did. My geometry experience wasn't so good in high school. My teacher didn't seem highly interested in. Exactly right. We'll see that in the next one. Angle, angle, angle doesn't work. So now we'll talk about the two that don't work. So there's actually just two three-letter combos that do not work. Angle, angle, angle. You can see that example they're giving right there. I'm just taking these out of your book. See those two triangles? They have the same three angles, don't they? But they're clearly not identical. One is a bigger version of the other. They are technically called similar. We'll get into that next week or the week after. Maybe end of next week. We'll get into similar shapes. So they are what's called, so meaning one is identical except for size. That's what similar means. One's just a blown up version of the other, like on a photocopy or something. You blow it up or shrink it down. That's what they basically are. But they're not congruent. Because congruent means identical. They're not identical. One's a bigger version, huh? So having three angles is not enough information. You can have the same three angles and not be identical, but you would be similar. All right, so that's not enough information. And then there's one other which is hard to remember. This one, angle, angle, side, side. So that's a little different than angle, angle, side. That one's okay. Angle, angle, side is good. Two angles and a side not between them. But two sides and an angle not between. Not between. That angle is not between. That one doesn't work either. That one's hard to remember. So, my job as a teacher, and it will become your job as a teacher, is to sit around and think of ways to help your students remember things that are hard to remember. And so, you know what I did? There it is. It's the bad word. There we go. Now you'll never forget, huh? Right? It's the bad word. So A, and the bad word. Everything else works. Those are the only two that don't work. It's a bad word, it doesn't work, and neither does A. So that's an easy way to remember it. So I'm just summarizing it right here. These ones do not work, A, and the bad word. All the rest, pretty much any other three-letter combo, will work. will be enough to prove two triangles are identical. Now you'll never forget that information. You've got it. All right. Here's a nice example. I made this example to prove that. Yeah, question. Good question. And what about SSA? Yeah, that's the same. They're the same, and both do not work. Yep, you're right. Yeah, they could write that either way. Good observation. Exactly right. And the same way, this one could be written SAA, and it's okay. Those are both the same. Yeah, so the order, the key is that it's not between. Whether it's in the front or the back, it's all the same thing. Yeah, good clarification. So AAS or SAA, those are both okay, because they're not the bad word. Either order really means the same thing. And this one here, those are both the bad word. Forward or backwards, they both are bad. They both don't work. And I made an example. There's great stuff online now. I remember when I told you last time I taught stuff was 13 years ago. Back then, there wasn't nearly the resources. It was so great. I was prepping. I just typed in, and within 3 minutes, I had this amazing applet where you could make triangles and do the angles for free. It's just amazing stuff. So I used it to show an example. There's an example of two triangles. And I thought I would have time in class to play with it, but I don't know. I don't know if we'll have time. Maybe, but probably not. I always say that. All right, but here it is. Look at the triangles I made. They have the same ASS. The bottom is the same as the bottom. See how those bottom sides are the same length? And the right side is the same. Left side. The left side's the same as the left side. See how this length is the same as that length? So they both have the same left side, the same bottom, and then this angle here is the same opening as that angle there. They have the same angle side, right? Angle not between the sides. Right, they don't have the same angle between the sides, clearly. You can see this angle is not the same as that angle, clearly, huh? So they don't have the same angle between the sides, but they do have this angle the same as that one. They have angle, see how it is? Angle, side, side, the same as angle, side, side, but they're clearly, obviously, not identical triangles. They're very different, aren't they? So that's a clear example of two triangles having the same angle, side, side, but not being identical. They're not even similar, are they? They're just completely different, even though they have the same angle, side, side. All right, so very easy. You too could find an applet to do great exercise. Easy stuff for teaching that's available. If you have time to play with that, good use of time. All right, so there's our summary again of what can be used and what cannot be. That's pretty much what we're going to do for this section and the next. That intro is what we're going to use. And now to the homework we go. Question number 1. If triangle tin is identical to triangle map, let me make that a little bigger for you. So triangle TIN. And then here's the way they write it. They write an equal sign with like a little squiggle above it. That's geometry's symbol for congruent. That means identical. So triangle tin is identical to triangle map. So they're making the statement. They're saying triangle tin is identical, congruent, to triangle map. If that's the case, and then they're going to ask us a bunch of things. They're going to say, okay, if that's the case, does that mean that side TN is equal to side MP? Does that mean that angle I is equal to angle M? And does that mean that side IN is equal to side MA? Well, you might think at first, well, yeah, if they're identical, they're identical. Yeah, but you got to make sure they're matching up the corresponding sides and angles. So let's take a look. There's two ways you can do it. You can actually draw a triangle. So I'll go TIN, and then you got to do the other one in the same order. So TIN, MAP, MAP. See how I went left, right, top. You can do whatever order you want. Just be consistent. So I went left T, right I, up in, then left M, right A, up P, so that I was consistent. That's what this is all about, is the order. So now, is it true that side TN, I'm going to make this bigger for you, does side TN, is it equal to side MP? That's their question. Does TN equal MP? Well, here's TN, here's MP. Yeah, that's the left side. They got to be equal, don't they? because they're telling us these two triangles are identical, so the left side of one of them has got to be equal to the left side of the other. Yes, that's true. Now, how could we have figured that out without actually drawing the triangles? Because you don't have to draw them.
The order of the letters are with the left.
Exactly. It's just all about the order of the letters. You can just go T and N are the first in the back, front and the back, and M and P are the front and the back, so it's good. As long as they're matching them up in the same spots, it's a go. It's going to be the same side of the triangle. So you don't have to draw it. You just have to check that the order's the same. That's all you really have to do. It's all about the order. So the order of that statement is very important. If they switched it, if they said triangle TNI is, is the same as map, that would be a different kind of statement than triangle TIN. The order matters. So when they make their statement, they're making it very carefully, and we need to follow their order because they're saying something specific. All right, so they said tin and map, so we followed that order. How about the next one? Is angle I, if you can see this, I'll make it a little bigger here. Is angle I congruent to angle M? Here's I, here's M. Do they have to be the same? No way. I's the right side, M's the left angle. No, they're different angles. They're different spots. Again, you don't have to draw it. You can just see here, I's in the middle of this one, M's in the front of that one. No, they're not in the same spots. It's the wrong order. So no, they're not corresponding. Right? All the sides and all the angles on the tin triangle has to be the same as the sides and angles in the map triangle, but only the right ones matched up. How about part C? IN and MA. So we come on down here. IN, is that congruent to MA? IN, so where's IN? Here's IN, here's MA. No, they blew it again. Wrong order. Right? IN are the back two, MA are the front two. So no, again, those are not corresponding. Those are different parts of the triangles. So they're just helping us to be careful to look at the order of the statement. Is that good? Questions, comments on that? On that? Yeah.
So T and M will be congruent, right?
Say it one more time, Sylvia.
The letter T and M, they will be considered congruent.
I'm sorry, one more time.
The letter T and M.
T and M? Oh, you mean, yeah, this angle? Yeah. Angle T and angle M. Yes, totally. Angle T and angle M are definitely equal to each other. That's right. Yeah, you've got it. Yeah, that's exactly right, because T and M match up, because they're both in the first position of the statement. Exactly. So it's just all about the position, isn't it? Just making sure the orders match up on that. Good. How about number 2? We got a couple of triangles, triangle on the left, triangle on the right. And they're wanting us to make the statement now. So again, the order of the statement is super important. They're starting us off by saying triangle QRT is identical to triangle what? So here's QRT. This is S over here. So they want us to make the statement, triangle QRT. When you write the first triangle, you could write it in any order. They didn't have to go QRT. They could have done RTQ, TRQ, whatever. Doesn't matter. But once you make the first triangle statement, then the second one must match the order. So can you write that? Can you write the second? So the triangle on the left, we're trying to say the triangle on the left is identical to the triangle on the right. But we're trying to write the correct order for the triangle at the right. So what's our order? STR is correct. Everybody see it's STR, not SRT. So I think the beginning is easy. You know that, so this one, let's look at the left one. So the left triangle went QRT. The triangle on the right, STR. Now I think we all know it starts with S. But why does it have to finish that way? Well, notice the triangle on the left finishes. Let me put these back and got too much drawing here. So QRST. So QRT finishes with what? The 90-degree angle, doesn't it? See how T is the 90? In the left triangle, QRT, T is the 90-degree angle. So therefore, if we're going to set up the same corresponding order in the triangle on the right, we've also got to finish with the right's 90-degree angle, which would finish with R. So see how T and R have to be in the same spots as each other? Because they're both 90-degree angles. So yeah, it's got to be STR, not SRT. Make sense on that? All right, so yeah, STR. Now coming on down here, it says, determine the corresponding congruent sides. So it's saying, okay, so now that you've made that statement, QR is the same as what? So QR is the same as ST, isn't it? And you can say ST or TS. The same thing either way. It doesn't matter what order when you're specifying a line segment, right? TS or ST, that's the same segment. And QT, which is here, is the same as what? SR or RS, either way. SR or RS. And finally, RT, that's right here. RT is the same as TR, or you could just say RT again. Either way. It's the same as itself, right? It corresponds with itself. And then they come down here and do angles. Bless you. Angle Q is the same as what? Here's angle Q. That goes with angle S. It's an S there. Angle S, that's right, angle S. And now they say angle QRT, if you can see that. Angle QRT. Let me try to get rid of some of this stuff here. So what's angle QRT? Remember how to do angles? You just trace them from Q to R to T, QRT. It's that angle, isn't it? QRT. Now that angle, QRT, in the left triangle is the same as what angle in the triangle on the right? This one right here, right? And how do you say that one? RTS or STR, either way. RTS or, sorry, I'm scribbling a little bit here. RTS or STR. Yeah, for the angles, you can switch which way. It's the same thing. You can't do that for a triangle statement. Everybody see the difference? When you're making a statement about a whole triangle, every letter matters. But if we're just making an angle statement, you're basically trying to say this angle here. There's two ways to do that. Start with R, then go to T, then go to S, or vice versa, STR. That's the same angle, isn't it? As long as the T's in the middle, huh? Either way, it's the same angle. How about the third one down there? Angle RTQ. Get rid of all these scribbles here. RTQ. Get rid of everything. So this is Q, T, S, R. So RTQ. RTQ. Oh, that's the 90. RTQ is the 90. So what's that the same as? Yeah, it's this 90 here, which is SRT, SRT, or you could switch it TRS, TRS, same angle, either way. And finally, what's the reason? Why is the triangle on the left identical to the triangle on the right? They give me some options here. Side angle, side, 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 side. HL, that's hypotenuse leg. I'm not going to spend any time on that. So anyway, why would those two triangles be identical? Yeah, they have side angle side, don't they? We know, go back here. We know that, see how it's marked on the diagram? This side and this side, those single marks mean they're equal. And, of course, this 90 and this 90. And then what's the other side?
The one that they're connected.
The one they share. So this is side, angle, side, the same as side, angle, side. Side, angle, side. Angle in between two sides. Side, angle, side. All right, there we go. Feel free to speak up if you want to clarify anything. Number 3, a truss used in house construction. Strengthen roofs is shown. Name two congruent triangles and tell why they're congruent. So they're saying they want me to start with the triangle on the left. Here, maybe I should make that a little bigger. I don't know if you can all see that. So they have this, and this are both 60 degrees. And this is A, B, C, D. This is 90. This is 20 and 20. Okay. So they basically, we're going to say the triangle on the left is identical to the triangle on the right. And so they're going to first make a statement. Which one of these, ABD or ABC, is the triangle on the left? ABD, right? Not ABC. What's ABC? That's the whole thing, right? We don't want to say that. We want to say the one on the left is identical to the one on the right. We don't want to say the whole thing. So the one on the left, ABD, is identical to the one on the right. So what order, if we do ABD on the left, A to B to D, remember every letter, the order matters in a triangle statement. It's very specific. If you're going to go ABD, what order do you have to do for the triangle on the right so everything matches up? Yes, CBD. CBD. They both have to finish with D because D is the 90-degree angle in both of them, isn't it? So they both have to end with D. D is the 90 for both of them. And what's the reason? Why are those two identical? Side, angle, side, yet again. Side, angle, side. They got a side, an angle, and then they share that common side in the middle again. Side, angle, side. How about number 4? Two triangles. Are they congruent, identical? What kind of information do we have on number 4 here? Yeah, it's angle, angle, angle. Those 3 angles are the same as these 3 angles. That's what those marks mean, the single, double, and triple angle marks. They're saying 3 angles in one triangle is the same as 3 angles in another. We know that's not enough info, right? We already know that one's not. But which one of the no's is it? They're kind of being pretty tricky here. Is it the first that says no, angle, angle, angle is not sufficient for congruence, it's not enough information, no, they're identical. 2 triangles are congruent, identical, only if the side lengths are congruent. That's not true. You don't have to have the sides, right? So, B, no, angle, angle, angle is not enough. One triangle might be larger than the other. That's true. That's the problem with AAA, right? One could be a bigger version or a smaller version of the other on that one. So that's the right answer. All right, I'll keep moving, but let me know if you want me to slow down. All right, so here's number 5. We might spend the rest of our time here on number 5. We probably will. It's A through J. And then on J, they're going to have us refer back to a whole bunch of other ones. J itself has like 6 parts to it. All right, so here we go. It's a whopping problem. So it's a lot about just getting used to sides and angles and how they're spaced. So they're giving us this segment, and they're saying, down here, A, B, C, or D, which of those, it's multiple choice, which of those has the same side as AB and the same angle, CAB? That's what they're asking. They're saying, hey, you see this little angle thing, part of a triangle that we've made? Which of these options, A, B, C, or D, has the same bottom, the AB, and has the same angle there on the left? Which of those has the same bottom side length? Let's start with part A. Does A look good? The bottom looks the same to me, right? This AB length and that AB length look the same to me. That's good so far. But what about the angle? Is this angle the same as that angle? No. The angle is bigger. This angle's bigger, so it's not A. A does not have the same angle. How about part B? What about, is that side length the same as that side length? No way. The bottom's not the same. Too small, right? That side is too small, and the C has the same problem. The bottom is too small. The bottom is not the same as the bottom there, is it? So the answer is D, isn't it? That bottom is the same, and that angle looks to be the same as well. Even though the top is different, but they didn't say the top had to be the same. So they're just seeing if you can carefully follow their instructions. It is D. D has the same bottom and the same angle, even though it doesn't have the same top. Part B, I think part B is a real obvious one. Part B just says a triangle with sides 18, 27, and 36. So which of those four, A, B, C, or D, is a triangle with 18, 27, and 36? Just A, yeah, just looking at it. There it is. All right. How about part C? A triangle with sides of 9, 12, and 15. Like A, B, and C are all good. I mean, this is a triangle. Oh, yeah, no, not this one, huh? I don't know if you can see. That one has two 12s. Can you see that? Okay, this has a 12, and a 9. So that's wrong. It's supposed to be 9, 12, and 15. They said 9, 12, and 15. But A and C, this has 9, 12, 15. This has 9, 12, and 15. A and C both look pretty good at first. But one of them has a problem, huh? What's the problem?
It can't be C because the hypotenuse has to be the longest side.
Yeah, do you remember? Yeah, and again, we'll get into the specifics of all that right triangle stuff in a couple weeks. It might be 3 weeks, it's a little ways away. But yeah, do you remember enough from that's got to be the longest side in a right triangle? The side across from the round, that has to be the longest. So this is a fairy tale triangle, right? This is make-believe. You can't really have, they can write whatever numbers they want, but that wouldn't exist in the real world. You really couldn't take a 9 and a 15 and that side be 12 and they really connect up like that. That really wouldn't happen. Just because they wrote those numbers there doesn't mean that really, a triangle really exists like that. It couldn't, right? So A is the only real triangle that would exist. The 15 has got to be the longest side. It's got to be the one across from the right angle. It's called the hypotenuse. You might remember. We'll get into that in probably 3 weeks or so. Good on that? All right, good. So we're through A, B, and C. We just have D, E, F, G, H, I, and J. All right. So on to C. Oh, yeah. There's more to C. We didn't finish C yet. All right. There's the first part of C. And now they're going to ask, okay, you got it. And then that one right there, what kind of triangle is that? Isosceles acute, scalene right, isosceles right, equilateral. Remember what we talked about with all those words? Are those getting a little more fluent to you? What is it? Scalene. Yeah, what is scalene? It's been a little while. What's scalene mean? All three sides different. Yeah. So yes, indeed, that's a scalene right triangle. What does isosceles mean? Two the same? Yeah, so that one doesn't have two the same. They're all three different, huh? There we go. All right. And D, a triangle with sides 1, 6, and 8. Triangle with sides 1, 6, and 8. Well, this has 1, 6, and 8. This has 1, 6, and 8. This has 1, 6, and 8. They're all looking good. What's the story there? Well, it's the make-believe thing again. They can write whatever numbers they want, but in the real world, none of those triangles exist. And the answer is D. Why? How do we know none of those triangles exist? You know, Kendall?
Isn't it like there's like a rule that they have to, if you add the sides together, they have to be bigger than the other side?
Good, you're right. That is the rule. But you know where I always want to go? Why is that the rule? So there is a rule. Why is that true? I want to describe it in a way that just feels, because math is about truth on that.
Because if you have two lines that make an angle, if you extend them out, it has to be longer than the side that connects them. Because if they're folded out into a straight line, it has to be longer than it is if they're like this, if that makes sense.
Yeah, no, I know what you're saying. How about here's the way I've seen it most easily make sense for people over the years. So like say you're on campus somewhere, right? And you're going from point A to point B. And you have two options. You can go like over here to some other building and then go like that. I didn't mean to make that a right angle. It doesn't have to be a right angle. I'm just saying, any old place over here and then head up there. Right? You can go that way, go over here through point C. Or you could go straight. Which one's got to be a shorter path? This one's short. This is shorter. It's straight. Straight is shorter. I mean, right? We all know that. The shortest distance between 2 points is a straight line. Going out of your way has to be longer, right? Well, look down here for a second. Look at say this one. It's exactly what you guys are saying. If this is one going from point A here to point B there, what are our options? We could go we can go out of our way 1 and 6, which is a total distance of 7. 1 plus 6, right? 1 plus 6 is 7. Or we could go straight and it's longer. No, it's not. That's a fairy tale triangle. That can't be. Do y'all see that? The shortest distance between A and B has to be a straight line. There's no such thing as, I went out of my way and it was shorter. Now I know you might think, I do that with driving. Yeah, maybe shorter time, but never shorter distance, right? You can't go out of your way and it's only 7, 1 and 6, and straight is somehow longer? That's not how the physical world works. The shortest distance between 2 points is a straight line. So those triangles don't exist like that, do they? So it's exactly what Kendall's saying and Cammie's saying, that if you add up two sides, it has to be bigger than the other side. Do you see, 1, 6, and 8 do not exist as a triangle. Why? Because 1 and 6 are supposed to be must be more than 8. Because going out of your way, 1 and 6, has to be longer than going straight, 8. Has to be more than 8. So in other words, if that other side was like 3, that would be okay. You could have a triangle with 3, 6, and 8, because 3 and 6 are longer than 8. But there's no such triangle that has 1 and 6. If you actually try real life, you'd have like the piece that's like, you'd have that little piece here that's like 1, and this would be 6, and then the 8 would be like longer. They wouldn't connect up. See how those ends could not connect to make a triangle? It just wouldn't really exist. Kevin?
A way that I've seen it shown as far as like you're trying to get someone younger to understand is to take 3 popsicle sticks and have them make a triangle.
Yeah.
And then you flatten it out, and then the 2 sides are going to be longer than the other side. So like if you make a triangle out of popsicle sticks, but then if you make them all flat, then where there's 2 popsicle sticks, it's going to be longer.
Oh, okay.
Than 1 popsicle
So just
stick.
make it all into one flat line, and the 2 are longer. Yeah, nice. I like that. Yeah. I know. I wish we had time to do some more hands-on stuff. That's fabulous when you're teaching. Because there's a real connection between that. This is where I kind of want to say, don't. You know how they always say the old rule? You're supposed to imitate. Don't do what I'm doing as a teacher, because I just don't have time in the college curriculum. We boom, 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 3 50-minute periods. That's all we got. But yeah, this is so much better to be doing hands-on. Don't you do this? Don't just stand up and talk at those little folks from a projector, right? Get their hands on that stuff, popsicle sticks, pinning those together, and yeah, excellent stuff. All right, so do what I'm saying, not what I'm doing, right? I'm a hypocrite. All right, let's go on. All right, so F. So we're on to F. A triangle with sides 18, 21, and 75. So, so 18, 21, 75. So which of, and it says included, that's right. The point of this part is they just want to make sure you catch the significance of that word included. So included means between. So they're saying, hey, which of these triangles has an 18, a 21, and an included, right, in the middle of, included between, 75. So which one is it? A, B, or C? Yeah, it's right there. C. Right? Got the 18, got the 21, and then the angle is between them. The 75 is between them. G. A triangle with 18, 21, and a non-included. So now it says non-included, not between. Not between. So which of those has an 18 and a 21 and a not between? Well, a couple of them do, don't they? Let me see. So here's an 18, and an 18 and a 21, and that angle, that 40, is not between them, right? It's not up here. That would be the between, right? It's not between them. That one's looking good. But so is this one. Here's the 18 and the 21, and there's the 40. It's not between them. That looks good. Here's the 18 and the 20. No, this one's bad. Here are the 40s between them, so it's not that one, is it? We're supposed to not put it between them. But what's up with B and C? They both kind of look good at first. One of those is a fairy tale triangle again, right? Which one can't really be like that, even though they wrote numbers that way? Wouldn't exist in the real world. Do you see it? Which one?
B.
Yeah, what's wrong with B?
The hypotenuse is shorter than
Yeah.
the sides.
Again, that's got to be the longest side, huh? You can't have 18 here and somehow 21's a longer side. That can't be. The side across from the right angle, called the hypotenuse, we'll get into that in 3 weeks or so, that triangle doesn't really exist. So the answer is C. That's the one that has an 18, a 21, and an angle, 40-degree angle, not between them, not included on that. All right. On we go. Was that H up there? We just did H. Oh, no, we're on H, huh? Yeah, H. So we have an 8, 8, and a non-included 40. So 8, 8, and again the non-included, not between. So which of these triangles has an 8, 8, and not between? So here's 8, 8, and there's the 40. That looks good. It's not between them. This is 8, 8. Okay, now that 40 is between them, so no way. And here's 8, 8, and that 40 is between them, so yeah, no, that's not good. So it's got to be A. Yeah, right? 8, 8, and the 40 that's not between them. That was okay. That was pretty easy. So 2 8s and a 40 not between them. How about I? A right triangle with legs 5, 10. The legs include the right angle. So 5, 10, and a right angle between them. Am I racing ahead too fast? What do you think about I? 5 and 10, and a right angle in the middle of them. A, B, C, or D. We good with A? A is the right answer, right? Just nothing, no special trickery there. Just 5 and 10 and the right angle, the 90 that's between them. Right? Whereas D's not right because it's got a 5 and a 10, but the right angle's not between the 5 and the 10. And C is just different numbers. All right, now J, we're to the last one. 4 minutes to go here. But, last one on just question 5 or whatever. We got many more questions, which we'll do on Friday. But for J, see how what I mean? It has part J. This is like unfair almost, huh? Part J has parts A through G. All is part of J. We're still on question whatever this is. 5, is it 5? I can't remember now. Anyway, so what they want us to do now is go back to all those ones we just did and decide which of them are enough information to be only one triangle. They say, for each of the conditions in the problems B through I, so they're letting us skip A, does the information determine a unique triangle, or is there more than one triangle that's possible? Now, we don't really need to go back because they give us the information right here. So like on this one, it says, a triangle with sides 18, 27, and 36. So we're supposed to check but there's going to be more than one of these we check. There's going to be several of these that we check. And we're supposed to say it's unique. It describes, there's only one triangle possible from that information. Is that true? If somebody says, hey, I want you to make a triangle, and I want it to have sides 18, 27, and 36, is there more than one way to do that? Could one child make take some popsicle sticks and 18, 27, 36, other child do 18, 27, 36, and the two triangles end up not being identical? Or would they have to be the same triangle? And how do we know they would have to be the same triangle? By side, 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 right? Because if two triangles have the same 3 sides, they are identical. There's only one way to make a triangle out of 3 sides. So yes, we'll click that box. Right? They're saying how many of these is unique? Yeah, that's unique. There's only one way to make a triangle with sides 18, 27, 36. How about the next part? Sides 9, 12, and 15. Well, it's the same thing. Yeah. Side, side, side again. How about the next one? 1, 6, and 8. Remember that? That's the one that was fairy tale. That doesn't work. 1 plus 6 is not more than 8. It's supposed to be. That one doesn't even exist. So no, it's not a unique triangle. It's not a triangle at all. How about part D? Equilateral. Sides 6. What does equilateral mean? All sides the same. So we're saying it's 6, 6, and 6. Yeah, so by side, 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 that's unique. Let's do one more. Triangle of sides 18, 21, and an included angle of 75. So if you have 18, 21, and an angle between them, say, hey, kids, I want you all to make a triangle that has an 18, a 21, and an angle between them that's 75. Is there only one way to do that, or is there more than one way to finish that triangle? By side, angle, side, there's only one way. Every triangle with 18, 21, and a 75 between them will be identical. They're all identical by side, angle, side. All right.